Assalamualaikum and a very good day. In this video, we are going to discuss about the function or graph of function of tangent. So basically for tangent graph, amplitude, it doesn't really matter. And the period for tan graph is pi over n. It's different from the cosine and sine graph. For tan graph, the period is not 2 pi over n but pi over n. And one cycle looks like this. And there will be one cycle in every pi over n. And C is the shift. Okay, as usual, positive going upwards. If we have negative value of C, we are going to shift downwards. Okay. If you press your calculator, tan 0, which is just tan 0 radian, is equals to 0. Tan 90 or tan pi over 2 is undefined. Okay. Tan 180 or tan pi is equals to 0. Tan 270 or tan 3 pi over 2 is undefined. And tan 360 degrees or tan 2 pi is equals to 0. How does the graph looks like? Basically, the tan graph will have asymptote at the undefined parts of the graph. Okay, so we will have asymptote at 90 degrees and 270 degrees, or 2 pi over 2 and 3 pi over 2. The graph will look something like this. One cycle, okay, one cycle for tan graph is this. This is considered as one cycle. And if we do it continuously, the graph will look something like this. Okay, so it will go on forever. It will not touch the dotted lines. It will never touch the dotted lines, but it will go close to the asymptote. Okay, this is known, the dotted line is known as the asymptote. Okay, so Y and X. Right, let's have a look at the first one. Again, for tan graph, A doesn't matter. And period is pi over n. In this case, our n is 1 because we have A, tan, and x. N is 1, so equals to pi, means one cycle in every pi. So if we have to draw the graph, 2 pi, pi over 2, 3 pi over 2. For every pi, there will be one cycle. Means that in the middle will be the asymptote, and the graph will look something like this. And for the next pi here, again the same thing. There will be one asymptote and another cycle. Okay, so the graph will go close to the asymptote, but it will never touch the asymptote. So basically this is just the graph of y equals to tan x. Now let's have a look at the second example. Y equals to 2 tan 2x. Again, amplitude A doesn't matter, right? And the period is equals to pi over n, which is just equals to pi over 2 for every pi. There will be one cycle. There will be one cycle in every pi over 2. Okay. And we need to draw the graph from 0 until 3 pi over 2. So as usual, I will just draw 0 until 2 pi. So this is 2 pi, 3 pi over 2, and pi over 2. And in every pi over 2, there will be one cycle. Okay, so take note that in every pi over 2, there will be one cycle. Basically, in every pi over 2, there will be one cycle. For the next pi over 2, pi over 2, pi over 2, we will have one cycle. So basically, you can just draw the asymptote. For every pi over 2. So when you draw the graph for the next pi over 2, one cycle, the next pi over 2, another cycle, the next pi over 2, another cycle. So that is y, that is x. But the thing is, the question wants us to draw from 0 until 3 pi over 2. Means that we need to stop at 3 pi over 2. So we can erase this part here and just stop at 3 pi over 2. Okay. So that is the end product, where we stop at 3 pi over 2. So this graph is graph of y equals to 2 tan 2x, such that x is from 0 until 3 pi over 2. Okay, let's have a look at the third example. So again, we deal with modulus. Modulus is just reflection, not say reflection, but negative part must be positive. So again, our A doesn't matter, and our period is equals to pi over n, which is pi over 1, since n is equals to 1, which is pi. So 1 cycle in every pi, 1 cycle in every pi, since we have to draw the graph from 0 until 2 pi. And 1 cycle in every pi means that for every pi there will be 1 cycle. Starts from 0 up, going down, and for the next pi there will be another cycle. So this is for y equals to tan x. The next one we will modulus, means that the down part will go up, so the graph will look something like this. So means that you move that and that part to the top part, so eventually you will get the graph that looks like this. Okay, next example, y equals to a negative tan. Negative refer to reflection about x exists. So again, A doesn't matter, the period is equals to pi over n. In this case, our n is equals to 1, so pi over 1, which means that pi, 1 cycle in every pi. So if you have the graph once from 0 until 2 pi, so we have 2 pi here, pi over 2, 3 pi over 2, and 1 cycle in every pi. So for every pi there will be 1 cycle, and for the next pi, again the asymptote. So this is for y equals to tan x. The next one we add negative. Okay, when we reflect, we have negative in front, we need to reflect about x exists. So means that from here it will become this. Okay, and reflection down here to become like that, and like that. So as if okay, again, reflection about x-axis, just imagine, so it goes down like this. Okay, so done with that part. And reflection about the x-axis, it becomes like that, and reflection about the x-axis becomes like that. So now we can erase this part. Reflection about this x-axis becomes like that. So this is your final product. Okay, that is the graph of y equals to negative tan x. How about y equals to tan 2x? Again, amplitude doesn't matter for tan graph, but the period. We will have pi over n, which is pi over 2, means that one cycle in every pi over 2, and we need to draw from 0 until pi. So this is pi, this is pi over 2, and one cycle in every pi over 2. So for every pi over 2, there will be one cycle. So another cycle for the next pi over 2. So this is your graph. This is the graph of y equals to tan 2x, where we stop at pi. Okay, for the last example. Again, amplitude doesn't matter, and we have period equals to pi over n, which is pi over 1, which is just 1, and we have shift c equals to 1, so means shift up 1 unit. Okay, so basically we are going to start the first one with tan x, and from inside to outside. Second one is the negation, reflection about x-axis. Third one would be the modulus. And lastly, we will have to shift up. Okay, start with tan x first. Okay, we start with tan x. So graph for tan x. Say, oh, I didn't have the range there, but probably we can take from, let me see. Okay, never mind. Maybe we can consider range from 0 until make it 2 pi, right? Okay, so first we draw tan x. Okay, y equals to tan x, Right, so how do we do that? Just the basic graph, 2 pi, and this is pi, 3 pi over 2, pi over 2, and looking at the period is 1 cycle in every pi. Okay, for every pi there will be 1 cycle. Okay, so for every pi there will be 1 cycle. So we have the asymptote here. Okay, so 1 cycle. Again, the same process, asymptote here. 1 cycle. Done with number 1. Number 2, we need to consider reflection. Okay. First, we already have time. Now we consider the reflection about the x-axis. So reflect everything about the x-axis. It becomes sorry. Okay, done with the reflection. Next one is modulus. Okay, we need to modulus. So modulus means that everything from down have to go up, and down go up, and up and up. So the last one we need to shift plus 1, shift. Okay, shift plus 1 means that if it's from 0 becomes 1. So the graph will look like something like that. Let me make it much more precise. Okay, so this is 1. So everything will shift 1 up, and now we can erase the old graph. So this is what your graph looks like finally. So this is just the graph of y equals to modulus negative tan x plus with 1. Y-axis, x-axis. Okay. So your final product. So it's your final product. Okay. Alright, now we've done with the graph of tan. I hope that you will understand all the the basic way to sketch the graph of trigonometric functions. In our next video, we will discuss on the problem solving involving graphing of trigonometric functions. That's all for today. Feel free to ask me questions. Thank you. Bye-bye.